So after studying the introduction for the gymnosperms, now you know that what kind of plants we are dealing with. Okay, so gymnosperms exactly comes after the pteridophyte and before the angiosperm on the mother earth, and they were developed on the evolutionary line exactly after the pteridophytes, and how the reproductive structures are there, how the leaf stem and roots are there, and how these pteridophytes grow in a harsh condition, how they are adapted to the such as xerophytic conditions, all we have seen in the introduction to the gymnosperms. Okay, now consider the concept of progymnosperm. This is exactly mentioned in your UPSC main syllabus, and this concept of the progymnosperm is actually a very important while studying the plant kingdom, because these are the connecting link between the pteridophytes and the gymnosperms. Okay, now consider we are dealing with the paper 1 and the chapter number 3, that is the Phanerogams. In that you have to first study the gymnosperm, and in that first you have to study the concept of progymnosperms. Okay, now consider the concept of progymnosperms. See, some of the fossils of the Devonian and the Carboniferous period of the Palaeozoic era have been found, which were earlier thought to be belongs to the pteridophytes, but now were thought to be nearer to the gymnosperms. All through are not the gymnospermous status. See, what is conflict here? See, there are some fossils which are found in today's date that they were belonging to the Devonian and the Carboniferous period. Now these are fossils, whatever the fossils were found there in the form of such rocks. Okay, now these are fossils were earlier considered as they were quite related with the pteridophytes. Okay, they looks like a pteridophytic plant, but after the detailed study, we came to know that they were quite nearer to the gymnospermic plants. That is, they are showing the gymnospermic characteristics rather than the pteridophytic characteristics. That literally means these pteridophytic characteristics are present in these plants but are not in the 100%. Okay, because some portion of it is showing the gymnospermic characteristic, and some portion of the plant is showing the pteridophytic characteristics. Then these such a plants, although it has not given the complete gymnospermous status, but they are still placed under the gymnosperms, because although they are look like a pteridophytes, they are showing some characteristics which are relating with the gymnosperm. Then the question arises, then in which group we will place them, whether it is in a pteridophytic group or in the gymnospermic group, because they are showing the both the types of the characteristics. Okay, so although they are not the fully gymnospermous status, they are still placed under the gymnosperm because they are quite nearer to the gymnosperms. That is why the new group is created, which is called as the Progymnospermacida. These progymnosperms are neither the pteridophytes nor the complete gymnosperms, but they are just a connecting link between the gymnosperms and the pteridophytes. So as you know, the connecting link where always the critical importance, because these are showing the evolution of the land plants, because these plants or this group of the progymnosperms is showing that the gymnosperms were originated from the pteridophytes. So we have the fossil record right from the Devonian and the Carboniferous period that the plants were existed there, which are literally transforming right from the pteridophytes to the gymnosperms, and all these plants were later taken into the category of the progymnosperms, that is, which are going to convert into the gymnosperms, and that is why they were famously called as the progymnosperms. Okay, now understand this. See, when the connections were found between two such a fossils, that is that when they have compared the two such a fossils, that is the fern like the fronds of the Archaeopteryx. Okay, Archaeopteryx plant is found, and it's the fronds were exactly like the ferns, and as you know, fern is the group of the pteridophytes. So fern like fronds were present in the Archaeopteryx, and the gymnosperm like trunks of the Palaeozoic. So you can see this is the Palaeozoic trunk, and this trunk like feature is present in these plants. So trunk, whatever the trunk is present there, this trunk is showing the gymnospermic characteristics, while the frond is showing the pteridophytic characteristic. So when the fossil records of the two fossil records were compared together, like the Archaeopteryx and the Palaeozoic, this Archaeopteryx is showing the presence of frond-like leaves, which are very much like of the ferns, and the tree, the gymnosperms, the Palaeozoic is showing the trunk, which is very similar with that of the gymnosperms, because gymnosperms shows the very solid tree trunk. Their stems are very solid. Generally, in the pteridophytes, you will not find the solid stem, the very solid stem or the large stem or the stem with the secondary growth, but the frond-like leaves were found in the ferns. So some characteristics of the ferns and some characteristics of the gymnosperms were found in the similar plants, and that is why we have taken them to the progymnosperms, right? See, according to the Bonamo, the progymnosperms are the plants exhibiting the features of the pteridophytic reproduction and the gymnospermic anatomy. See, what are scientists saying about these plants? See, according to Bonamo, what he is saying, these progymnospermous plants are those plants which are showing the reproduction which is pteridophytic type of reproduction, but their anatomy, when we consider their anatomy, it's a gymnospermous anatomy. So the one plant group is showing the characteristics of the both the plant groups, which is called the pteridophytes and the gymnosperms. So pteridophyte and gymnosperm characteristics are found in the same plants. Like the pteridophytic reproduction is there, and the gymnospermous anatomy is there, which is present in the same plant group, which is called as the progymnosperm. So from this point, with the common sense, you can also conclude that these pteridophytes may have got under the certain kind of changes, and these pteridophytes are going to convert into the gymnosperms. And what we are finding in the form of fossil record is the transitional levels between the pteridophytes and the gymnosperms. Okay, so according to Bonamo, what these plants are showing, these plants are exhibiting the feature of the reproduction in the pteridophytes, while the anatomy of the gymnosperms. See, the progymnosperms are thought to be form of a link between the Psilophytopsida, which is the group of the which belongs to the pteridophytes, right, and the gymnosperms. See, what they are saying, the progymnosperms are nothing but the connection between the pteridophytes and the gymnosperm. The very particular order of the pteridophytes is the Psilophytopsida. We have studied this Psilophytopsida, the one member of it. The Psilophytopsida and the gymnosperms connection is found there in the form of progymnosperms. So there is a one group of the pteridophytes which is called as the Psilophytopsida. These are slowly getting converted into the gymnosperms, and whatever the transitional forms are there, whatever the in between forms are there, they are all comes under the category of progymnosperms. Now see, some paleobotanists consider these progymnosperms to represent the origin of both cycadales and the coniferals. See, whatever the progymnosperms are there which are present between the pteridophytes and the gymnosperms, later these progymnosperms are given rise to the cycadales and the coniferals. Cycadales and the coniferals, both these orders belongs to the gymnosperms. So on the evolutionary line, what we first have is the pteridophytes. Okay, then we from these pteridophytes we are seeing that the gymnosperms may have arisen. Okay, but through the fossil record we have find some intermediate form which are placed under the progymnosperms. Okay, that is from these gymnosperms later the gymnosperms are going to originate. So progymnosperms are there which are got converted into the gymnosperms, and the pteridophytes are there. These are pteridophytes later got converted into the progymnosperm, and these progymnosperm may have got converted into the gymnosperm. Specifically in the gymnosperm, the cycadales and the coniferals. Okay, these two orders may have arisen out of these particular progymnospermous plants. So this is like the connecting link between the pteridophytes and the gymnosperms, which are called progymnosperms, and these progymnosperms later may have given rise to the cycas like plant and the conifers like plants. Okay, now see, the progymnosperms are actually not the true gymnosperms. See, this is very important. One thing should be clear to you, that whatever the progymnospermous plants are there, they are not truly gymnosperms. Why we are saying that? Because they are showing the reproduction which is of the pteridophytic type. So how you can place them under the gymnosperms? That is why we have to create the special group which is called the progymnosperms, because we cannot directly take them to the gymnosperms, because all the characteristics of the gymnosperms were not followed by these plants, and hence they are not true gymnosperms. Okay, always remember that the progymnosperm is the connecting link between the pteridophyte and the gymnosperm, and hence they are not true gymnosperms and are still classified by some botanists as a pteridophytes. Okay, now saying completely them as a pteridophytes, it is not also a right thing, because they are not completely pteridophytes. If they are showing the very strong trunk, then this characteristic is of the gymnosperms. So how you can place them into the pteridophytes? But still there are certain botanists which are saying that this the pteridophytic group is slowly converting into the gymnosperm, and that is why these are still come under the pteridophytes. Okay, but in actualness, the progymnosperms are neither the gymnosperms nor the pteridophytes. Actually, they are sharing the characteristics of the both. They are showing the reproduction methods of the pteridophytes, while the tree trunk or the anatomical features of the gymnosperms. So literally we cannot place them either into the pteridophytes or in the gymnosperms. Okay, but the one thing is clear, they are not the true gymnosperms. Okay, now see, Stewart in 1981, what he has to say about this, he considered the discovery of the Progymnospermopsida as a landmark event which has enhanced our understanding of the vascular plant evolution, and more than any other finding after the discovery of the rhyme flora of the Ctenodosperms. Okay. Now see what Stewart is emphasizing upon. What he is saying, the discovery of the progymnosperm is very important in the to understand the evolution of the vascular land plants, because whatever the pteridophytes are there, which are the first vascular plants, these are first vascular plants has given rise to the gymnosperms. But how they has given rise to the gymnosperm, this process can be understand by using these progymnosperms, and that is why these progymnosperms are of critical importance when we study the evolution of the vascular plants. So vascular plants are there. These vascular plants, which are called pteridophytes, are slowly converting into the gymnospermous plants, and these gymnospermous plants, how they got created from the pteridophytes can be understood by using the progymnosperms, and that is why the Stewart is emphasizing that the discovery of a gymnospermous is a landmark event in the study of the vascular plant evolution on the land, because they are throwing the light on the various aspects that how could the pteridophytes have given rise to the gymnosperms. Right now, see, Beck has divided the class of progymnospermopsida into the following three orders. Okay, following three orders can be created in the progymnospermopsida, and this classification is given by the Beck scientist. Okay, now the very first order is called as the petals, then the second is called as the aneurophytals, and the third is called as the protopetals. Okay, first is petals, second is called as the aneurophytals, and second is called as the protopetals. Okay, now consider the first out of them, that is called as the petals. See, this order is equivalent to the archaeopterygids of the pteridophytes. So whatever the archaeopterygids fossils are there of the pteridophytes, these fossils are quite related with the petals order. Now see, the plants are moderately complex. How the plants are there? Plants are moderately complex, shows the moderately complex lateral organs. Okay, so whatever the lateral organs are there, these are the moderately complex. Their xylem was compact. Okay, xylem is there, vascular xylem is there, vascular whatever the vascular strands are there in the form of xylem and phloem. Xylem is found is quite compact form. Okay, it is found in a quite compact form, and these have been considered as a possible ancestors of the conifers. Okay, from these petals member, the conifers may have arisen. Now the members of these petals in the form of fossil record we have is the Archaeopteryx, then the Archaeopteryx, and the Palaeozoic and the Pitys. Okay, all these fossil forms which comes under the order petals, they are showing the pteridophytic as well as the gymnospermic characteristics, but there are some gymnospermic characteristics which are comparable with the present day conifers. So these petals can be considered as the pre-ancestors for the conifers. Okay, whatever the conifers are there today in the gymnospermic category, these gymnosperms may have got created out of the order which is called as the petals. Okay, now consider this. Second one is called as the aneurophytals. See, this order is equivalent to the order of protoperidales, that is, which is the subclass of the primophycals of the class Phaenicopsida of the pteridophytes. Again, these aneurophytals were also comparable with the pteridophytes because they are showing some similarities in the structural form with that of the pteridophytes. Okay, now the plants had the very complex pinnate lateral organ. Okay, as you know, we have just seen the pinnate lateral or pinnate lateral leaves were present in the gymnosperms. So this characteristic of the pinnate lateral organ is comparable with the gymnosperm, but still there are the reproductive methods which are comparable with the pteridophytes only. Now their xylem is dissected at the several with the several small medullary rays. So there is a development in the xylem. Xylem is not simple, just like which is found in the pteridophyte, but it is more like of the gymnospermic characters. Okay, and it is considered as the pacnoxylic. Now monoxylic wood and the pacnoxylic wood, it is a separate topic. We are going to compare these two in the form of one video lecture. Okay, now here we have to remember that the wood is a pacnoxylic type of wood, and there are the xylem which are dissected by the medullary rays. Okay, so these medullary rays, pacnoxylic wood, all these are the characteristics of the gymnosperm, while on the other hand the reproductive methods are of the aneurophytals, where is comparable with that of the pteridophytes. So again, the second order in these progymnosperms is giving the characteristics of both, that is the gymnosperm as well as of the angiosperms. The gymnosperms. So gymnosperms and the pteridophytes, both the characteristics can be found in the aneurophytals, and these particular order of the progymnosperm can be considered as the ancient or the ancestor stock for the present day gymnosperm. See, the bore apparently leafless lateral branch system, which is ultimately terminated into the small sparsely branched dichotomous branch. So literally we have the stems which are leafless. Okay, just like branching is there, but the leafless branching is there, but ultimately it is terminated into the dichotomous branch at the apex. Okay, so this kind of structure is there in these plants. So some portion of it is showing the pteridophytic habit, and some form of it is showing the gymnospermic habit. So again, it's a connecting link. Of course, it's a connecting link because it is under the progymnosperms. Okay, aneurophytals, according to Beck, it's the order of the progymnosperm itself. Okay, now consider the branching pattern. How was the branching pattern is there? The branching pattern is either helical, which is found in the aneurophyton, or the desiccated, which is found in the Tetrazhalopteris. Okay, so Tetrazhalopteris is there, aneurophyton is there. Both these kind of a plant is showing the helical and the decussate type of the branching. Okay, or in a one plane, can be found in the one plane only. You can observe here in this particular plant how the branching is there, right? The sporangia were born terminally. Observe, terminal sporangia were present in these plants on the pedicels, forming the cluster or the panicles. Okay, just like there is a presence of pedicel and there is a formation of a cluster. Okay, formation of cluster is also there. So the branching pattern was helical to desiccated type, and the terminally they possess the sporangia. So you can understand from this morphology that of course there are some certain characteristics of the pteridophytes, because pteridophytes also shows the presence of the sporangia which is born at the terminal end. Then there are branching which is of a decussate type. This desiccated type is found in the gymnosperms as well. Okay, so this Tetrazhalopteris or the aneurophyton is again present between the pteridophytes and the gymnosperm, showing the characteristic of the both. Okay, now consider this. No representatives is known to be the heterosporous. See, these are not heterosporous, which is making them typically as a pteridophyte. Okay, in this particular order, you will not find the heterospory. Now, heterospory, if there is a heterospory, we can say that either it's a pteridophyte or the gymnosperm. But if there is an absence of the heterospory, then literally these are coming to the pteridophytes, because there are pteridophytic members which are not heterosporous. Many pteridophytic members are the homosporous members. Only the 8 living genera are showing the heterosporic condition. But on the other hand, the gymnospores are the heterosporous plant. Gymnosperm shows the presence of two kinds of the spores. Now, if these are plants, that is the plants just like the aneurophyton and the Tetrazhalopteris, if they are not showing the heterospory, they are quite related to the pteridophytes and not to the gymnosperms. Okay. Now, these have been considered as the possible ancestor of the cycads. Okay. That is, the cycads types of the plants may have arisen out of this second order. Okay. Example for this is the aneurophytopteri, then Palaeozoic, then Relimia, and Tetrazhalopteris. Okay, all this example you have to carefully remember it. Okay, because you have to, if the UPSC asks you about the evolution of the gymnosperm, then there is of course the concept which is called the progymnosperm, and under there is a concept of this concept of progymnosperm, you have to give this all how these particular orders are quite comparable with the present day gymnosperm, right? The one order petals is comparable with that of the coniferals, while the other one can be comparable with the cycadales. Okay, now consider the third one, which is called as the protopetals. Okay, now the represented by the single genus of the protopetes. Okay, there is only the single genus. This group is considered by the paleobotanist as the possible ancestors of the petals and the aneurophytals. Its leaf traces were shows affinities with the cycads. The leaf traces which is found by these particular protopetes is comparable with the leaf traces which is found in the cycads, while its wood suggests the affinities with the conifers. Okay, whatever the conifers are there, whatever the woods are there, it is showing the comparison with that of the conifers, and the leaf traces were of the cycads. So again, you can consider this genus, particular genus which is called as the protopetes, it is comparable with that of the cycads as well as of the conifers. So basically, what they are trying to say in the progymnosperm is that they are the nothing but the ancestor stock for the gymnosperm, in particular the cycads and the conifers. Okay, conifers and the cycads are the two groups. These cycads and the conifers must have originated from these progymnosperms, which are laterally originated from the pteridophytes. So from pteridophytes there is the origin of progymnosperm, and from progymnosperm there is the origin of the cycads or the conifers. Okay. Now see, due to the presence of some early stages of the heterospory, see some early stages of the heterospory is shown by these particular protopetes. Again, I am telling you that if there were the early stages of the heterospory, this characteristic is comparable with that of the pteridophytes, because whatever the earlier heterospory was there, this was first shown by the pteridophytes in the form of 8 living genera. because these 8 living genera is showing the presence of the heterospory, and the early stages of the heterospory were typically first found in the pteridophytic plants, and hence this particular order, that is Protopetals, is also comparable with the pteridophytes. So now this may also belongs to the pteridophytes, for example Protopetals. Okay, of course they are comparable with the pteridophytes, and example for this is the Protopetals. So from all these three orders, what you can conclude is that all these three groups, all these three orders are showing some or other form of the pteridophyte characteristics or the gymnospermic characteristics. Now all these characteristics, when we compile together, we came to know they are literally the progymnosperms, and their ancestor was the pteridophytes, and from these progymnosperms the newly created plants were the gymnosperms. Right now, see some of the characters shared commonly by all the three orders, that is we have studied these are three orders. These similar characteristics which is possessed by all these three orders of the Progymnospermopsida includes. Okay, now this is very important. When we studied the three orders of the Progymnospermopsida, all these three orders show some similar characteristics which are comparable either with the pteridophytes or the gymnosperms. Now let us consider them one by one. What type of characteristics they show? See the woody habit. Now woody habit literally means they show the woody stem. Now woody stem are those stem which shows the secondary growth. Okay, that is the huge woody stem which can support the huge plant. This woody habit of the stem is found in the gymnosperm. Okay, you can easily see the secondary growth in the gymnospermic stem, and this woody habit, which is also found in the some members of the pteridophytes as well, but majority of the time these were found in the gymnospermic plant. So this woody habit is comparable with that of the gymnosperm. All these three orders, petals or the anaerophytals and the protopetals, all these are showing this woody habit. So woody habit is literally comparable with the gymnosperms. See the complex system of branching. Now complex system of branching is shown by the pteridophytes as well as by the gymnosperm. Okay, whether it's a pteridophyte or gymnosperm, both show the complex type of branching there, but the more complex branching is found in the present day gymnosperm. Okay, then there is a pycnoxylic secondary wood made of a closely packed tracheids and the narrow rays. Now this third point is typically belongs to the gymnosperm, because pycnoxylic secondary wood is only found in the gymnosperm. So you can say that this is a typical pycnoxylic secondary wood which is found in the which is found in these particular orders, giving them a characteristic feature of the gymnosperm. So no doubt they were the intermediate form, they were the transitional form. Okay, now then the fourth one is the dichotomous and the pinnate pattern of a fertile organ. Okay, whatever the fertile reproductive organs are there, these are showing the dichotomous and the pinnate pattern. Again, this is comparable with the both pteridophytes and the gymnosperm. Then the terminal sporangia were also present in the pteridophytes, were also present in the gymnosperms as well. So whatever all these common points are shown by these particular order, all these particular orders are showing the characteristics of the both pteridophytes and the gymnosperms. And rightly we have taken them all to the gymnosperms, progymnosperms. Okay, why we are taking them all to the progymnosperms? Because literally you cannot say it's a complete pteridophyte or it's a complete gymnosperm. That is why we place them all the three orders in the under this particular heading, which is called as the progymnosperms. Okay, now consider, see, since the protopetals occurred in the lower Carboniferous period, Relimia and the Anaerophyton Germanicum in the middle Devonian, and the genera such as the Tetrahylopteris and the Archaeopteris in the upper Devonian age, Boramo opine that the direct line of the evolution of these genera appears to be the impossible. See, very important point is there. See, according to the view of Bonamo, what he is saying, see, on the one hand, the Protopetes, these are originated in the lower Carboniferous period, right? Then the Relimia and the Anaerophyton were originated in the middle Devonian. Then the genera like Tetrahylopteris and the Archaeopteris were originated in the upper Devonian age. Okay, so if there are ages, there are different ages in which all these plants were occurred, then the common line is impossible for their evolution. Okay, there must be the polyphyletic origin. Okay, the common line is not possible there. Okay, because they were arising on the different ages at the different timings. Okay, and that is why they must have arisen from the some different kinds of the evolutionary line. That is why the Bonamo is open that the direct line of the evolution in these genera appears to be impossible. direct line is not there. There must be the branching, or the evolutionary branching tree should be there. And through this branching pattern of the evolution, all these plants may have got originated. Okay, the simple straight line is not possible of the evolution. Right? See, most probably the evolution did not progress from one order to the another, and the chief morphological characters were evolved quite independently from one another. See, whatever the characteristics which are found in the progymnosperm, they must have originated independently from one another according to the environmental condition at that time. Okay, they were not descendant directly. They were not descendant directly from the common source. All these characteristics which are found in the progymnosperm, they must have originated at the different times according to a different environmental condition. Whatever the dichotomous branching is there, whatever the terminal sporangia is there, whatever the woody habit is there, okay, all these characteristic feature may have evolved independently from one another and not on the straight line. Okay, according to the environmental conditions. See, on the basis of the similarity in the basic organization of the fertile organs, two independent evolution line may be traced. See, if you study these progymnosperm carefully, you will come to know, if you go through the fertile organs, whatever the fertile organs they create in their bodies, we can create the two evolutionary lines by studying these particular reproductive or the fertile organ, okay, in the members of the progymnosperm of Sida. So, by tracing the two evolutionary line, we can say how the fertile organs in these progymnosperms may have got created. So, one thing is sure, the one line is not there. Direct descendants is not there. One line is not possible, but there are many lines. At least two can be defined for the fertile organ evolution in these progymnosperms. Okay. Now, see, one line is exemplified by the Relimia to tetraxylopteris type of Phanerophytes, in which the fertile organs were very complex and the number of sporangia were very large. See, what is one line is saying? According to this one line, which is found in the Relimia like plant, okay, the fertile organs are very complex. Okay, whatever the fertile organs are there, these are showing the very complex nature, and these are present in a very large number. Okay, they are present in a very large number, and they are showing the very complex characteristics. Okay, now the another line of the evolution, okay, this is the another line of the evolution exemplified by the Ramelia to the Archaeopteris type, is in which the reduced type of a fertile organ is there. Okay, fertile organ is of a reduced type were present, and the sporangia were quite few sporangia were there. So one line which is coming from the Relimia, okay, right from the Relimia to the tetraxylopteris type of the Phanerophytes, while the another line is straight away from the Relimia to the Archaeopteris type. These two lines show the different kinds of the fertile organ development. On the one hand, you will find the very complex sporangia with a very large number of the sporangia were present there, and it's very complex. And the very small number of the sporangia were present on the other hand, and these are very small in number as well. Okay, and the simpleness is also there. Okay, so now we are talking about the progymnosperms. Okay, and as we have discussed largely that the progymnosperms are nothing but the transitional forms right from the pteridophyte to the gymnosperms. So whatever the in between lines are there between the pteridophytes and the gymnosperms, all these lines are comes under the progymnosperms. Now these are progymnosperms, okay, showing the characteristics of both pteridophytes as well as the gymnosperms. So exactly at what time and how this transition takes place, it is difficult to certain. Okay, but from the fossil record, we can conclude one thing, that from this pteridophyte, the gymnosperms may have got arisen through the intermediate group, which is called the progymnosperm. See, although much can still not be said about certainty of about the evolution of the progymnosperms. Some probable evolutionary trends of this group, we can discuss it right now. But what they are saying here is that not much knowledge we have about the evolution of these progymnosperms, because whatever the progymnosperms today we find, how these progymnosperms have got evolved from the pteridophytes, on this particular topic we do not have much knowledge. Okay, whatever the knowledge is there, this knowledge is not found how these particular pteridophytes have got converted into progymnosperm, and later this progymnosperms has given rise to the sacadales and the coniferales. Okay, coniferales and the sacadales were originated from these particular progymnosperms. So much of the light is not found on this particular topic, that how this pteridophyte is got converted into the progymnosperms. But there is a transitional levels. Let us consider one by one. See the three-dimensional to the planted type of branching system. That is the three-dimensional type of branching system which is found in the earlier pteridophytes. It is now getting converted into the planted branching system through this transition. Okay, then the unwebbed to the web type of leaves. Okay, unwebbed leaves were there earlier in the pteridophytic group. Then the web leaves can be found in the progymnosperms, or the terminal appendages is there. So, from the unweb to the web leaves, this transition is also occurred through these pteridophytes to the progymnosperms. Then the spiral to the opposite dissected phylotaxy. So, the arrangement of the leaves on the main axis, whatever the main axis is there in the pteridophytes, this main axis is showing the spiral present of the spiral phylotaxy. Now, from the phylotaxy, opposite dissected phylotaxy is got created in the progymnosperms. Then the homospory to the certain evidence of the heterospory. That is homospory, which is typically found in the most members of the pteridophytes. It is the heterospory were also found in the progymnosperm. So from homospory to the heterospory, this transition also occurred there. Then from the protostelic to the cephanostelic type of anatomy, that is cephanostelic anatomy is found in these progymnosperm. And as you know, the protostele as well as cephanostele were both found in these particular pteridophytes. But the cephanostele is considered as a more advanced as compared to the protostele. So this transition has definitely occurred right from the three-dimensional to the planted branching, then unwebbed leaves to the webbed leaves, then the spiral phylotaxy to the opposite dissected phylotaxy, from homospory to the heterospory, from protostelic to the cephanostelic. This transition have occurred. But how this occurred, we don't know about this. Okay, what type of environmental conditions were there? How the time has allowed this particular plants to got converted into the new kind of plant. Okay, so the exact sequence we do not know, but what we know that such a kind of things has happened in these plants. All these five kinds of the transition were occurred actually. Okay, so this is how the evolution of the progymnosperms may have taken place from the pteridophytes. Now consider the paleobotanists such as the Bonamo and the Beck. Okay, we have understand the views of both. The Beck classification we have followed, and the Bonamo's views also followed. Okay, now they opine that the gymnosperms were evolved from the progymnosperms. So whatever the progymnosperms which are evolved from the pteridophytes, these progymnosperms has given rise to the gymnosperm. So on the evolutionary line, according to the Bonamo and the Beck, first we have the pteridophyte, then we have the progymnosperm, and then we have the gymnosperm. That is from the pteridophytes, the progymnosperms originated, and from progymnosperms there is the origin of the gymnosperms. So the primitive aspect of the aneurophytals of the progymnosperms is very well established, because the structures are comparable. When we consider the progymnosperm with the pteridophytes and the gymnosperm with the progymnosperms, the structures were comparable, and hence we can establish a well-defined line there, and we can say that in general, according to the Bonamo and the Beck, that the progymnosperms were originated from the pteridophytes, and gymnosperms were originated from the progymnosperms. Now see, these are members extend farthest back in the geological column, include the three-dimensional branching pattern, terminal sporangia, and the protostele. Okay, because these members, when we go back in the geological column, they shows the presence of three-dimensional branching pattern, terminal sporangia, and protostele. All these were the ancient characteristics of the pteridophytes, and hence it is showing that on this particular line, that is from the pteridophytes to the progymnosperm, and from progymnosperm to the gymnosperm, this evolution has taken place. Okay, so understanding how these progymnosperms have got created, this is a complex thing, but there is a generalized idea that they may have definitely got created out of the pteridophytes, and from this progymnosperm, the gymnosperms may have got created. Okay, now see, these members must have led to the U-stele found in the Archaeopteryx, okay, which is the progymnospermous order. So in the progymnospermous order, there is Archaeopteryx, and these members may have led to the formation of a U-stele. Okay, the whatever the conifers and cycads are there, conifers and cycads showing this particular type of stele, and here we can compare this progymnosperm with that of the gymnosperms, right? See, six layers were also advocated for the evolution of the Archaeopteryx from the same protostelic ancestors. So many scientists are there which are saying that these progymnosperms were exactly the ancestral stock for the formation of the gymnosperms. Okay, now consider the close relation between the aneurophytals and the Archaeopteryx were also evidenced by the discovery of ray trichids. That is, the ray trichids were found. The discovery of ray trichids were saying that the aneurophytals and the Archaeopteryx were they were in a very close relation with each other, and groups sitting in the secondary wood of the Archaeopteryx and the Archaeopteryx and the Trichoxylon of the Aneurophytals. See, whatever the setting of the secondary wood is there in the progymnosperm, it is due to the presence of ray tracheids. And these are ray tracheids were found in the progymnospermous category. And later, this secondary wood may have transferred to the gymnosperm, because this secondary wood is not found in the pteridophyte. The ray tracheids were found in these particular aneurophytals and the archaeopteridales, and these archaeopteridales and the aneurophytals, due to the presence of ray tracheids, they may have got create the secondary wood, which is the characteristic feature of the gymnosperm. So, as we are discussing, there are many topics relating with this particular progymnospermic plants. But what is clear here is that the pteridophytes are the originators of the progymnosperms, and the progymnosperms are the originators of the gymnosperms. And there are many fossil evidences to support this particular evolutionary line. Okay, many scientists are there which are following this particular line. They are giving the evidence of the three-dimensional branching system to the planting branching system, formation of tree rachets, and formation of the secondary wood, etc., etc. Okay, now consider this. Some paleobotanists were also believe that the aneurophytals of the progymnosperms have give rise to the upper Devonian and Carboniferous members of the pteridospermials via Calimopataceae of the Paleozoic pteridospermi. See, what they are saying exactly here, because many new words are coming here, because the classification of the progymnosperm and the earlier pteridophytes is very complex. What they are exactly saying, that the transitional lines were existed between the aneurophytals of the progymnosperms to the pteridospermitals, that is the pteridophytes. So the connecting link are many. There are many connecting links according to the paleobotanists. Paleobotanists are those botanists which study the paleology. Okay, whatever the ancient fossils are studying scientists are there, they are called as the paleobotanists, and there are many views regarding how these particular progymnosperms are got created out of these particular pteridospermitals. Okay, now see, Beck is also advocated that the conifers were originated from the archaeopteridales and the progymnosperms of the progymnosperms. Okay, that is the archaeopteridales were the group which has given rise to the conifers. This we have discussed earlier as well. Okay, and the progymnosperms are literally responsible for creation of the today's gymnosperms. So whenever you talk about the progymnosperm, one, you must understand the two things, that it's the transitional line between the pteridophytes and the gymnosperm, and they are not true gymnosperm and they are not true pteridophytes, because characteristics are shared. And this is an important discovery on the evolution of the land plants, because whatever the pteridophytes were there first, these have got converted into the gymnosperms through the line of the progymnosperms, and that is why they are of critical importance on the evolutionary line. So this is all about this topic. Okay, thank you very much for watching this video. Please like this video, share this video with your friends who are studying the botany, and if you haven't subscribed to the Botany channel yet, please subscribe to the Botany channel for UPSC examination. Again, thank you very much for giving your time. See you in the next video lecture. Thank you.